Hello guys, welcome back to our question 1 of the 2017-18 test, and we just found this dw over w process. So in this video we're going to find the answer to this first part, which is going to consist of this expected value and this expected value. To find this first one, this dww over dt, we need to first divide by dt, which is simple. We'll just rewrite the process, dw over w divided by dt. In the first side, this first term, we'll cancel our dt. And on the second side, that's an r. Man, I can't read my own handwriting. I can't imagine how bad it must be for you. Plus sigma sr. Try to be more beautiful. So that dt goes away. And then here, I'm just going to stick this dt on the outside. And the reason for that is that dz divided by dt doesn't really mean anything, but it's going to fix itself in a second when we take expected values. So we just let him come along for the ride. So as I said, let's take expected values, and we need to recall that the expected value operator is linear, and it's also monotonic. So that means is that it's going to pass through addition, and the sum of the expected values is equal to the expected value of the sums. So this first term has nothing random. This stuff's all known at time t, and this stuff is all known at time t. So the expected value of this is equal to itself. It actually falls out of the expected out. It just passes straight through. Now over here, like we said, we can distribute the expected value. F over dt is not random, so that goes on the outside. Sigma s is not random, but dz is random. That's a random variable, so it passes in here. And then here, sigma r is not random, but dzr is random. So the expected value distributes to that. And recall that a dz Brownian motion process is defined, any of our dz's, as a normal with a mean of 0 and a variance of dt, which means that the expected value of dz, of course, is 0. So this is 0, and this is 0, and as a consequence, this whole thing over here is just 0. And the expected value will be this first term here. And so that's the answer to the first part. For the second, we're going to need to calculate the square of our Wealth process. So we'll start by finding dw over w squared. And to do this, let's think about our dw as two chunks. An A chunk, which will be all of this stuff, it's going to color. All of this here, we'll call this A, and all of this here, we'll call this B. We square it, we're going to get A squared plus 2AB plus B squared. Can we throw anything away? Yes, we can. dt squared is just 0, so A squared is 0. A times B is going to have dt times dz, so this is just 0. So all we need to find is B squared. So let's do it. Move back down. Our B term was F times sigma s dzs plus sigma r dzr, and we're going to square this whole thing. And that will be equal to F squared times sigma s squared dt. This is a variance. The variance of dz times dz is dt. But for the cross term, we need to be careful, because that one, we need to add that covariance term. So we're going to get sigma s, sigma r, and then dzs times dzr, we are told, is equal to rho sr dt. And then at last, we get sigma r squared dt. Great, and we can then factor out that dt. And we recall that this whole thing in the middle was defined to us as sigma sr. So we get sigma s squared plus sigma, I'm sorry, 2, there's a 2 here. 2 sigma sr plus sigma r squared, all times dt. And that dt term's about to go away because the question has asked us to divide by dt. So dw over w squared divided by dt, d divided by dt, and we have our answer, that this will just be this first term without that dt. So there you have it, the expected value of dw over w divided by dt and dw over w squared divided by dt. In the next video, we'll look at maximizing the utility function and finding the optimal f for an agent in this economy.